In this question, we're given the function f of x, shown here, and then we're asked to determine the derivative of f of x. And then from there, we're going to determine the values of x for the function to be differentiable. And then we are going to find the equation of the tangent line when x is equal to 9. So this part should look a little bit familiar, right? We've been doing this even in the last unit there. But now we're going to use our tool of finding the derivative, right? Because the slope is the derivative. So, all right. So first off, in order to use our derivative rules that we've been using, we got to expand this and simplify it up a little bit. So let's do that first. So we're going to say f of x is equal to, and then since this is squared, right, I'm just going to write it as multiplied by itself right off the bat. So x minus 3 over the square root of x, and then x minus 3 over the square root of x. Okay, and then we'll actually distribute. We have to get rid of these brackets so that we just have individual terms that we can take the derivative of. So the next step down here, we're going to have x times x is x squared, and then x times negative 3, this one, x times negative 3 over x squared. This would become negative 3x over, or sorry, not x squared, square root of x. And then the same thing for our middle term. This will be minus 3x over the square root of x. And then for our last one, this becomes negative 3 times negative 3. This becomes positive 9 over, and then just looking at the denominators of these two now, right? Square root of x times square root of x. That's just x. Okay, now let's collect our like terms here, because you can actually think of the x over square root of x part of this as the like term, right? So we've really got negative 3 minus 3. This is the same thing as minus 6x over square root of x, and then plus 9 over x. All right, now not a big fan of the square root in this, so let's get rid of that. I also want to get these x's up to the numerator. I don't like them to be down the denominator to apply my derivative rule. So let's do this. We have 6x, just writing the top. And then this square root of x part, what I want to do is, well, that square root of x is really x to the power of a half, right? And it's down in the denominator. So I'm going to do this. I'm going to call this x to the power of negative a half, just by moving it up to the top here, right? And then plus, I'm going to do the same thing with the x down here. I want this to be up in the numerator, so I'm going to call this x to the power of negative 1, just to bring it up. It's looking pretty good other than this. We can combine those though, right? Because we've got x times x to the power, different powers here, but we just add exponents when you multiply. So now let's do that one. So we have x squared minus 6. And now we just have to add, so 1 plus negative, so 1 minus a half. Now, in your mind, I would call that 2 over 2, right? So that we've got the same denominator. So that's going to be 2 minus 1 is 1 over 2. So we have x to the power of 1 half plus 9 x to the power of negative 1. All right, so looking back on that, this is still just f of x written in a different way, right? We haven't taken the derivative yet, but it is primed. It's ready to go. So f prime is equal to, now we'll actually take the derivative, right? So taking the derivative of x squared becomes, well, we'll bring the 2 down, so this is 2x. Right, and then there's just a 1 up there. We won't write it. Now this 1 half, we'll bring that down as well. So this is negative 6. Negative 6 times a half. That's 3. Okay, so I'm good to write that right now. X. Okay, and now 1 half minus 1. Right, because that's what we do here. Right, we subtract 1 from the exponent. So 1 half minus 1. So 1 half minus 2 over 2. That ends up being negative a half. That makes sense, right? If you're at a half and you subtract 1, you're at negative a half. Okay. Now plus. Now bring down the negative 1. So if you like, I can call this minus 9x. And then just careful which way you go here, right? Because we're still subtracting. So negative 1 minus 1 is negative 2. There you go. There's our derivative. Now, it'll be a little bit more helpful if we write this derivative without negative exponents or fractional exponents. So let's write this again now. So this is 2x minus negative a half. That brings it down to the denominator. So this is 3 over, and I'm going to write this as a radical right now too. The square root of x, right? Because it was really x to the power of a half down there, right? And I know x to the power of a half is really the square root of x. So I'm going to write like that right now. Minus, and then this becomes 9 over, and then bringing the negative down becomes x squared. And that is our derivative. Remember what that is? That is also the slope. The slope is the derivative. So what this does is it allows me to plug in any value of x, and that is the derivative at any point on that graph, right? Okay, so now part 2 of this says, where is this function differentiable? Okay, so if you remember, functions are differentiable when there's no sharp corners or non-permissible values. Like if the function doesn't, if the derivative doesn't exist at all, it doesn't exist. So there's a couple places here. It's similar to like non-permissible values on our derivative, right? Is that if I look at either one of these, right, x is not allowed to be 0, right? Because we can't divide by 0. So it can't be 0 in that case, or in that case, right? Because then you'd be dividing by 0. Okay, so 0 is excluded. Can't derive it at 0. And the other one we have to look at, when you look at just this one on its own, what kind of number can't you take the square root of? You can't take the square root of a negative, right? So if we're going to write this now using interval notation, we're going to say that it is, well, and here, I'll write it right up here too. So it's differentiable from 0 to infinity. Now, if it included 0, right, we would have put a square bracket, but it does not include 0 because you can't divide by 0 either, right? It can't be negative numbers because of the square root, and it can't be 0 because we can't divide by 0. Okay. Now, find the equation of the tangent line to f of x where x is equal to 9. And you might be thinking, oh, we got to do that limit thing again, right? But we don't. We now have an equation for the slope at any given point, right? So we know x is equal to 9 now. So let's do this. We'll say f, here, I'll come down here. F prime of 9. This will tell me the slope when x is 9 is equal to 2, and then instead of an x, I'm going to put a 9 in there, minus 3 over the square root of 9, minus 9 over 9 squared. So if we put this all in, so f prime at 9, we get, well, actually we'll show each step. So we've got 18 for that, minus, and this becomes 3 over 3, minus 9 over 81, which is equal to 152 over 9. And this was the slope. Okay, so we're almost there with our with the equation of our line, right? Well, actually, so that was this, that we could wrote that in there too, right? 152 over 9. All right, so now express the equation in general form. So probably easiest, again, like usual, it's probably the best if we can put this into point slope form first. So y minus y1 is equal to m x minus x1. So from there we got y. Oh, what's our y1? So we just got to do a little bit of work here. We got to find y1. So let's do that over here. Okay, so our x value is 9, and we know our original function. That was f of x. So f of x terms right up here. So let's find out f of 9 is equal to 9 minus 3 over the square root of 9 squared. So f of 9 is equal to 9 minus 1, right? Because square root of 9 is 3. So 9 minus 1 is 8 squared. So f of 9 is equal to 64. Okay, so that's our y value, right? That's the y value when x is 9. So we'll say minus 64 is equal to our slope we just found to be 152 over 9. And then x minus, and then our x value is 9. Okay, so now if we're going to put this in general form, I'm just going to clear the denominator here by multiplying everything by 9. So now we have 9y minus 576 is equal to, and then our 9's canceled. That was the whole point there. So now we have 152 x minus 9. Okay, and now we're going to have 9y minus 576, which is equal to, and then just distributing this one in, we get 152x minus 1,368. I knew what that was already. Okay, and then from there, we just need to, well, again, in general form, that's going to be ax plus by plus c is equal to 0. And I'd like the a value to be positive, ideally. So I'm going to leave the x over here, bring the 9y and the negative, or then the, minus 576 over to the other side. So we get 0 is equal to 152x. And then minus 9y. And then this becomes minus 792. And there you go.